That's supposed to be a bracket on this side.
Possibly. Yeah, it's a bracket. I just probably mistyped it. Alright, so let me know which question you guys have. I have one more thing I had to do is turn on the QuickTime. Who's this? Who are you? Elaine. Hi, Elaine. Factor. Do you know how to factor? You're doing great. It's factor. You don't know how to factor, do you? Okay, so I'm gonna teach you. Give me a second. I'm gonna do it on the board. I'm gonna do it on the board. Alright, so some people don't know how to factor something, which is I'm more scary about if you don't have factoring skills. So factoring skill is actually not too bad if you just manage how to do certain thing better than other things. So let's just say if I have something like this, right? I'm gonna give you a couple different situations. So 9x squared plus 66x plus 21, and this looks very, very scary, and this very looks like a very ugly factoring. Now, for you, you have to have a factoring skill when leading coefficient greater than 1. Here's how I do it. This is called box method. So I'm going to do 9x squared, 21, and 66x here. It's called first, last, middle. So you switch the order a little bit. Otherwise, it's going to be FML, which is, we all know what it stands for. No, it's not. It's FLM. Okay, so first, last, middle. So the term had to switch. Once you switch, you just need a breakdown. Says, okay, well, what times what equal to this? So in this case, I don't know. I'm gonna try 3 and 3. And if I do 7 and 3, it doesn't seem like I need to get there. So it seems like I need to do. If I do 7 and 3 here, that's gonna give you 21 and 9. But this part is the adding part. Okay, this part is the adding. So this spacious spot is adding those two. 21 plus 9 does not give you 66. So that means something is wrong. So then you say, okay, well, besides 7 and 3, what other things you can have? Well, of course, 21 and 3, right? 21 and 1, 21 and 1, right? And 21, that's going to give you what? 63. And this is 3, right? And that becomes 66x. So therefore, just pair diagonally. So it'd be 3x plus 21 times 3x plus 1. Actually, I did it wrong because I should have factored out a 3 first. You make my numbers much easier to manage. So it should be like this. 3 times what? 22. X plus 7. It should be like this, and then you can do things because you still can factor out 3 here. So that's going to be x plus 7 times 3x plus 1. So either way, it's going to be 3 times x plus 7 times 3x plus 1. So it's called a box method. If you cannot factor, use a box method. I promise you, it's a lot easier than whatever things you do because 9 times 21 is a big number if you do AC method. If you don't believe me, try this. 6. If you don't believe me, try how to factor, which is 6. If you do know how to factor, great. If you don't know how to factor, try to factor 6x squared minus 15x minus 9, and I'll show you how easy that factor is. Now, I'm going to just add a little bit. I'm going to say greater than 0 like this. But at first, you got to factor. So can you factor it right? True. You can factor out 3 and then divide by 3. You can divide by 3 technically, yes. Make your life easier because they are factorable. If I divide it by 3, that is going to give you 2x squared minus 5x minus 3, right? Am I doing okay? I can divide by 3 on both sides. That's just going to go away. So I still have to factor this, though. First, last, middle. 2x times x. Well, I can do 1 and 3, but that's not going to... Wait, hold on. 1 and 3, am I going to get it right? No, that's not going to be correct. Pay attention. That's going to be... They both have to be negative here. So if they both negative, the problem is this multiplication does not give you a -3. So this is actually wrong arrangement. So then you say, why is that? Why is that wrong? Because you have to have just one negative number here. So the only way that this is gonna work is gonna be 3 and 1. So that's gonna be 6x and 1x. And remember, this is adding, and one of them need to be negative. So I'm gonna choose this one to be negative. So that's gonna be, again, diagonal pairing. Yes.
Is it faster than the AC thing?
It is faster than AC if you deal with this question. Think about 9 times 21. Because now you only break down the 9 and you break down the 21 and you put a combination of both. Now, if you do AC, is you do composition of 9 times 21. Just even 9 times 21 is 189. To factor 189, there's a lot. But this factor of 9 is much simpler, and factor of 21 is much simpler. So you break down to small pieces. So that's why I told people. And also, like, this is good for this type of factoring. So like, it's like e to the x minus e to the x minus 2 like this. A lot of people don't know this is actually factorable. Do you know how to factor this? It turns out this is a factorable if you just e to the 2x, negative 2, e to the negative x. Well,
The last part was 5x instead of just 5x
which one?
for the where it's the first last middle of the box.
Oh, this one's negative? You're right. So this one need to be negative. So this one's going to be negative. You're right. It's going to turn off. So this one's become negative. So this one is going to be 2. This one's x minus 3. This is plus 1, right? Thank you. So like even this type of factoring is very easy because it visually shows the variable. So you can say, oh yeah, e to the x times e to the x, because the exponent rule is going to be e to the 2x. And this is just 2, 1, this is 2 e to the x, and this e to the x. One of them need to be negative because this is negative 2. So this has to be negative, and this had to be negative. So it'll be e to the x plus 1 times e to the x minus 2. So even that is like a box method has a better illustration of how to factor it, dissect it into more details so student can see those. You know, so for me, I think the box method is the one I teach to all students. I always say if student can factor these questions using AC method, beyond my guess, using AC method. If you cannot, you can break down to small pieces. It's much more illustration. You just need to make sure the last column is added to B66X. And sometimes can be both negative and sometimes can be one's negative. So it depends on the L term, depending on this term. This is -3. Therefore, that -3 times 1 has to be -3. This part is adding, so you had to add up to be -5x. If you try a couple times, you'll figure out this way is actually pretty good. I have a student that knew how to do AC methods. She's from Brazil, and that she is she always knew how to factor something. And then she says, my way is better because it breaks down to more details. And she actually go to MIT. So she's still factoring the same way, even though she's at MIT. So that proves to me that it's actually very good. And I also taught the first year, I taught Algebra 2. I taught AC method. And my factoring test was so hard that everybody failed. So I had to ask like somebody who's better than me. So at the time there was somebody named Miss Nguyen. She teach calculus. So I went to Miss Nguyen and I says, hey, can you teach me how to teach factoring more efficient? And Miss Nguyen says, you know, you just had to teach this way, use the box method, student can always get it. And of the second year when I taught, I remember this girl named Jasmine. Jasmine didn't know how to multiplication table work. She got 100 on her test. And she never, and I gave a hard factoring. I gave like 9x squared minus 1700x or plus something, and she able to figure it out very easily. So box method is better. So if you can use box method, use it. If you don't need to use it, great. Next questions. Oh, sorry. Let me finish this question, this part. This is a greater than 0. You cannot just say 2x plus 1 greater than 0. X minus 3 greater than 0 like this and solve like this. This is wrong. This is wrong. This is the wrong answer. So I'm gonna say I don't know which question. There's a question there that looks like quadratic inequality. You're supposed to do something called number line test. So it'll be 2x plus 1 equal to 0, x equal to -1/2, x minus 3 equal to 0, x equal to 3. So now you're going to do something called number line test.
Outside of it, change it? Or?
No, it doesn't change. So I write down 2 factors here. Now, personally, Mr. Cooper is more experienced. Anybody from Mr. Cooper here? Okay, Mr. Cooper is more experienced as far as teaching the student because he teach calculus. So he actually teach you how to do number line test last year. Mr. Ollie never had to teach calculus, so he doesn't teach a number line test as much as we do. So if I taught pre-cal, I will teach him how to do number line test. So Mr. Cooper for us this part is excellent because most of her students know how to do number line tests. And which is that's a bigger part I need you to be able to do because we have a whole chapter require number line test. You have to test something that says between -infinity to -1/2. You're gonna test that say -1, -1 because -1 is less than -1/2. So -1 that's gonna give you a negative sign. -1 minus 3 is gonna give you a negative sign. That's end up to be positive. If you test between -1/2 to 3, what's a good number to test? 0. So then that's going to be positive and negative, and that's negative. And if you test something greater than 3, let's say 4, and then that's going to be positive, positive, positive. Now, this is not answering the question, however, because the question is right here. It says greater than 0. That means look for positive region. And that means this part and this part. So that means the answer is -infinity to -1/2. And depending on the question, this is greater or equal to, so this is going to be bracket, union from 3 to infinity. And that's my answer. Right? And that's how it goes. I don't think Ollie teach this number line test. Did she? Briefly? Okay. From what I heard, some student he didn't teach. I asked Jared, he says he didn't teach, so I actually teach yesterday. So yeah.
What you do against less?
What is 0 is less than? Good question. Then you will pick this region that's less than 0, which is between -1/2 to 3. And it's gonna be bracket because this is negative. If negative is less than 0, right? So this question is on the test. You had to know how to do a number line test. Yes.
How do you like say whether it's the region negative or positive?
Because two negative signs multiplied together is positive, and positive times negative is negative, and positive times positive is positive. Does that make sense?
Yeah.
And I test the number through to this two factors. I use a number and plug in. See, I don't need the evaluation of numbers. I just want to know, are they positive or negative at the end? Yes.
If there was more, you would have
What'd you say?
so if instead of like that, I like actually four, there'd be like another break.
Yeah, so good question. So question 17 is like that. Question 17 has 4 breaks. Yeah, has 3 break points and has 4 intervals. So question 17 has x equal to 0, x equal to 5, x equal to 2. That one is already on the video, so go watch the last video. I don't want to repeat that one, but you can try it and then go do them and then see if it works, because that one is harder. Yeah, so you can have multiple break. On chapter 4, when we deal with concavities, sometimes you have 3 breaks and there's 4 interval you have to test. And sometimes the things that you have to test may be 3 or 4. So you have to figure out which thing that you do test or which thing you don't test. Later on, you're going to learn, let's say it's x squared plus 4, you actually don't test on the part of the left side, because it doesn't matter what number you plug in, x squared plus 4 is always positive. So that doesn't need a test. That just exclude them. So let's just say this. If I ever have that says x squared plus 4, right? X minus 2, x plus 4. Like this. So the way you test, you still test at -4, 2. And you don't, because this one does not give you a 0, and this one also does not contribute to sign change. The only thing that you test is x minus 2 and x plus 4 here. And that's the only thing you test, because x squared plus 4 does not cause sign change. Because it doesn't matter what value you plug in, you never have a sign change. Yes, even degrade, and this also is positive 4. If it's x squared minus 4, then yeah, you're gonna get some negative sign changes. But x squared plus 4, you never have sign changes, so you don't have issues. Next question. You guys are too quiet. That's very dangerous. I sense failing. 17's on the video.
If you go back to where you were
Yeah, of course. E to the x times e to the x is e to the 2x. And you can, this can happen in sine as well. So those are the things that sine square of x minus sine of x minus 2. Last year, you probably, at Cooper's class, probably done that a lot. I don't know about Ollie, because I only hear rumors like from people, so I don't know, like, I don't know if Ollie is a good teacher, but I know Mr. Cooper knows what he's talking about. Cooper knows calculus. And matter of fact, that he's a lot more experienced in calculus than me. So I don't talk shit about him. I do sometimes, but in different way. The only reason why I disagree with him is I don't believe double block should exist, but that's me. But I have respect of him. He knows his math.
So with the E example, so the like the 12 to -2, that one you multiply, with the one to the right of it you add those two.
you still add this negative 2 e to the x and e to the x. You add together, it's going to be negative e to the negative x.
Yeah. -2 and 1. You add those.
Oh, this multiply. This multiply, and they multiply this way too. So e to the x times -2 is -2 e to the x. So inside the box is all multiply. Outside the box is adding.
And so e to the 2x is equal to e to the x times e to the x?
Yep.
Okay.
Because that's the exponent rule, right? A to the m times a to the n equal to a to the m plus n. So if a to the x times a to the x, guess what? A to the 2x. X plus x is 2x. Yes.
Question 15.
15, sure. Let's do 15. Would you mind to tell me the questions? What was the question? It's a long one. Okay, let me see if I can find it. $15. 15 not long. That's just linear equations. That's actually very easy. And what Ellie just told me that the parentheses is wrong. Yeah, that should be a bracket. That this is probably algebra 1. Less than -2 times ax minus 5 plus x. So -6x plus 3 plus 2 greater than -16x plus 10 plus x. So -6x plus 5 less than -15x plus 10. And that's going to be 9x. I add 15x on both sides. And I subtract 5 on both sides. So the 9x less than 5. X less than equal to 5 with 9. So if it's less than 5 with 9, so it'll be negative infinity to 5 over 9 bracket. Is a bracket. It's not a parenthesis. Question 16 is quadratic inequality. That one's on the portal. Equation or tangent line? Yep. How we ran out of voice. That's bad. It's true. Yeah. What?
I thought like 3 of them going wrong.
It's possible because I already told you yesterday there's 3 or 4 possible wrong answer, including the one actually I did in tutoring. Also, like there was one thing that I forgot to mention, so I tell you which one is it. So far as right now, I know number 4 has an extra answer, x equal to -25. It's part of the answer. And as of right now, number 12, the quadratic formula is wrong. So that one, I need to go back and redo it. I think you should end up with square root of 139. Or 129, 139. And question 15 is a bracket. Question 17 is also a bracket on the 5. Bracket on the 5 side, parenthesis on the -2 sides. The next question that possibly have mistake is question 36. It should be 5y plus 2x on the bottom. 28. 28 is 2 inside. 28. The inside is 2y squared, not 3y squared. What?
About 4.
Question 4.
Yeah.
Question 4 has a 2 answer, x equal to -25. I can go over that one, but it's on the video. Oh, it's on your test. She's looking.
25.
Huh? No, VC has a harder test. AB might have it too. I don't know. I don't remember what AB test I put in.
Question 4 is the other answer.
Yeah, a -25. Because if you square root both sides, you're gonna get positive and negative.
Yeah.
And I forgot to take account into the negative. It's not about square root, but
Scroll back to 8, right? So
15.
it was on the other page. It was just right there. Yeah. Thank you. So it would be what?
You can't fail this time. I'm gonna give you some extra credit, but it's gonna be impossible for you guys.
I checked this. Yesterday I checked it because I had a question, and they said that -25 is not zero, right? Understand why they means
I don't believe they are right. So here I'll show you. Possibly, but I don't believe so. So let's go to decimals, right? And oops, my bad. Graphing calculator, and just do x minus 2 parenthesis to 2/3 minus. So you see on the left side there is an intersection at -25, and on the right side it's a 29. So the reason why I think this is funny because
it's like because of 2/3.
yeah, because you can actually have -27 to the -3 power, the 3 roots first, right? So -27 to the 3 root is what?
-3.
-3 squared is still gonna give you 9. So I don't believe they are right, and the graphing calculator show you the same as well.
I tried that. I did what you were teaching on recording. Do you know something?
Yeah, you did great.
Okay, so this is like
Yeah, so then you have to
That's-
solve for it.
yeah, okay.
So actually go to
Thank
negative
you.
one.
For number 17, I'm kind of confused on like the
17.
yeah,
You're doing great.
I was following the video, but I don't understand like the -2 part on how that is greater than or equal to 0.
-2 is not including is because if you plug in -2 on the bottom, you'll cause something divided by 0. So it should be a parenthesis.
Okay, but I'm confused. So for the it's like the negatives and the positives up here. So I don't. So is it because this is negative, this is positive? And
No, okay, so this is negative, that means everything's negative. So it doesn't matter what number I plug in.
Okay.
If it's square, it's always a positive. But positive times negative is always negative. So the whole thing is negative. And then you plug in that says -3 into here. -3 minus 5 is negative. -3 plus 2 is negative. So if you negative times negative equal to negative.
And then if I plugged in,
If I plug in the next one, it'll be -1. -1, this one's going to be negative. -1 minus 5 is negative. -1 plus 2 is positive. So that's going to be negative times negative is positive. Positive times positive is positive.
oh, okay. All right. Thank you.
You're doing good. Yeah, you can.
Here's on the line test.
Okay. What was your question?
So I think you have to use it for number 3.
For number 3, yes, you have to do a number line test. And if you do the test, you should end up to be positive, negative, positive, but you gotta choose the negative region because they say less than 0. If it's less than 0, then you pick a negative region.
for 7, I had gotten positive 1 nice and positive 1 instead of negative.
Okay, the reason being is I think this is a negative sign here.
Is there a negative sign there?
Pay attention to questions. Yeah, I think I have a negative sign there.
Oh yeah, there is.
That's okay.
You.
No problem. Um,
Oh, to like 2/3. Very natural response. So as you like, what I said, yeah, I mean, it was loving, but it was still like the logical thing. So it would have to be negative 1/3.
is the Madison here? Daniela's is here or not? Daniela's? Daniela's is not here, right? Tony, Robert, Corbin, Jack, Elaine, Michaela, Ding, Chase, Vincent, Yulia, Aiden, Madeline, Lucas. Lucas is not here. Was he here yesterday?
Yes.
Oh yes, no, I'm just kidding. Absent. Ethan Sorrell,
Yes.
Jack Stamman, Madeline, Rajesh, Irving, Catherine, Kaywin.
You're sorry.
Okay.
This, yes. I mean, I guess you already go around today. So it's really like.